Alu. Well, that's the way we say hello in Greenland. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit about indefinite integration. Now, children, in this lecture, we will be looking up what integration is, when is it that it is indefinite, and when is it that it is definite. Further, I will also be telling you about the product rule of integration, which we also know as integration by parts. After this, I'll be leaving you people with an interesting question which has the product of a logarithmic function and an inverse trigonometric function. Then I'll just not be leaving you people like that. I'll also be discussing the question with you and then giving you people a second explanation which will ensure that any speck of doubt remaining anywhere will be all cleared up. Now, children, all of this and much more, as I'm also planning to have jokes cracked in between, more interesting facts about this place, and also serving you people with the sweet delicacy of this place when you're really hungry. So be with me till the end of this lecture and enjoy all of this. So let's start, children. First, the concepts. So the first thing that I want to tell you people is, what is integration? Now, children, if we have a function, right, let's say some function which is, say, some f of x, which is equal to some 3x square plus 17x cube plus 39, right, some any adverse function, right? Now, when you want to find out the derivative of this function, then you change the function. That is, I'm sure you people must have studied differentiation a little. I'm not going to discuss that in detail here. For that, there are other lectures to which you should go and look up, right? Now, obviously here, I like to tell you people that you should look up the playlist of your class where you will get a group of lectures from which you can benefit a lot, right? If you want more, then obviously in the description, I have given you a link where you can share your email ID and I'll get back to you and help you with any problem that you have, right? So, children, here when we talk about this indefinite integration, I was giving you an idea that this is a function. Then when we differentiate this function, we change this function a little, as we write this to be 6x plus 51x square, obviously plus 0 because the derivative of a constant is 0. Now, this is how this function changes. Now, if you want the old function back, then what do? Is we integrate this differentiated function. That is, we talk about integration of f dash x dx, and that, children, will give us what? It will give us the original function to which the constant of integration is added. The constant of integration is added because, like you saw here, when there was a constant and you differentiated it, it became 0. So if it is 0, it is not visible. As such, when you have your differentiated function like f dash x, there is nowhere that constant's sign. As such, you can't get it back anyhow because there is no trace of it. As such, you write plus c, which is the constant of integration, which serves as an evidence that there could have been some constant and we are trying to get the whole of the function back, right? Now, children, when we talk about this process of trying to bring back the old function back after it was differentiated is known as integration. And further, if suppose we have the integral of a function like we have some sine square x, which is, say, varying from minus pi by 2 to pi by 4, right? So here, as some limits have been written, so then this will be known as definite integration, as then you will be knowing that portion which you really want to integrate, right? And when there are no limits written here, then you do not know which portion of the function's graph is to be integrated, right? As such, you call it to be indefinite integration. Now, one thing more. When you talk about definite integration, then we tend to trace out some area of the function's graph under the graph above the axis, right? So all of this comes in definite integration, where we have some rules that we follow, and after that we find out the area of the graph that is required. Obviously, there is a couple of chapters for which to do this that you will have to study. That is, first is definite integration, and the second is finding out the area using integration. Now children, we will come to that some other time. At this moment, I also want to tell you people about the product rule. So if say now we have a product of two functions, like say some f1x which is multiplied with another function f2x, and then we have to integrate this product, then as you know that functions can be of different types, right? We can have an inverse trigonometric function, right? Or we can have a logarithmic function, right? Or we can have an algebraic function, right? Or we can have a trigonometric function, or we can even be having an exponential function, right? Now children, remember here that this order of writing is something which is very important, and this is how you arrange your functions. That means those functions which have first come in the order are to remain first in the order of the functions that are written. So if say we have a function which is say some x squared times of log of x, so you will quickly try and check whether this is in this order or not. Now here, as you know, that x square will be an algebraic function, and if you talk about log of x, obviously it's a logarithmic function, right? So as a comes after L, that means the algebraic function comes after a logarithmic function. As such, the algebraic function will have to be kept next. The logarithmic function will have to be kept first so that it can be integrated. Now children, thus this in the next step is going to be written as integration of log of x which is multiplied with x squared to be able to integrate this. Now why is it so? Can anybody from the class tell me? Yes, Mitali? Very correct. The way in which you keep the functions is actually, it will tell you that whether you'll really be able to integrate this function or not, because all functions, remember, cannot be integrated. So when we keep a specific order of the functions, right, as a rule below is going to show you just now, then the more integrable functions are kept on the right hand side, right? And the functions which are easily integrable, they are kept on the left hand side, right? So as such here, what we do is we will now talk about the integration of the product of a logarithmic function and an inverse trigonometric function in the question that we discuss. So now we have to go over to that, right? But before we go, I will quickly like to tell you people one mnemonic that you can remember which will help you in doing integration by parts. Moreover, what is this known as? This is known as integration by parts, right? That is, when there are two functions which are multiplied together and then this product is to be integrated, then we call it integration by parts. Now how we break it up into parts is now what I'm going to show you. That is, if suppose we now have integration of say some f1x which is multiplied by f2x, and obviously these functions are going to be any two functions which are of different types, right? So if one is x plus 1 and the other cannot be x squared plus 4, because their product will become a single algebraic function. Now in order to use this rule, you require the second function to be a different type of a function, like a logarithmic function, like an inverse trigonometric function, or anything like that, right? So let's say now that we have such two functions which are multiplied together, which has to be integrated, right? Now if it is to be done, the formula, children, is that you have to take the first function f1x out of integration, and then you have to integrate the second function f2x, right? And from that then you have to subtract the product of the integral the derivative of the first function, that is d upon dx of the first function which is f1x, which is multiplied with the integral of the second function, right? And whose integral again is going to be found out, right? So this is the formula. So I'll just quickly repeat this to you. When we talk about integration by parts, the formula which is to be applied is, if in accordance with this inverse, logarithmic, algebraic, trigonometric, exponential order of keeping the functions, you can remember that they are to be kept as if it is I late. You can just consider that you've gone to school late. I'm sure you must have done it many a times, right? So you can just remember it from there, and each of these alphabets now represent the different type of functions, right? So if two such functions are multiplied together, then what is the rule by means of which you are going to integrate this is known as integration by parts, right? So here what you do is you take the first function f1x outside, and then you integrate the second function, and from that is subtracted the integral of the product of the derivative of the first function with the integral of the second function, right? So here you can say that you have the sign of integration, and then you're talking about finding out the derivative of the first function, multiplying it with the integration of the second function, and reintegrating it, right? So that is the reason why I'm writing this multiplication sign in black, so that you can easily identify that it is to be the product, right? Okay, now as you can see here, that integration of the second function is being said again and again. That is why I said to you people that when we choose the functions, we tend to keep those functions which are easily integrable later in the order. Okay children, now I have a very interesting sum for you people. I like you people to quickly try it. I won't be able to give you much time. I'll just give you 10 seconds for trial, right? As most of you people are offline, so what you can do is you can pause the lecture and make sure you give it a longer try, as all the things which were required have already been told to you people. So use your intelligence and try and crack the sum. Okay, coming back. Now children, I think you all are sitting straight with your spine straight on a table and chair, and using no writing material now. That is, no copy, no book, no pen at this time. Right? Make sure that you're also sitting at a secluded place, so that there is no brother, sister, friend, your mobile, your TV, etc., which is disturbing you, right? And just focus exactly where my pointer is. So Mithali, where is my pointer? Yeah, it is at T. Now, where is my pointer here at this time? It is at M. Very correct. So wherever my pointer is, make sure your attention is exactly there, so that you're able to understand all of this with ease. Because remember, you also have to do this after this lecture, and do promise that you'll be doing it, because there's no point just watching this like a movie. You also want to do this when your examination comes, isn't it? Then you just don't want to sit just like a spectator who's just trying to see every friend of yours writing the examination, right? Okay, so now let's start this off. When we have this product, so what do we do here is we now talk about the first function, which is the logarithmic function, and the second function, which is the inverse trigonometric function. Now what is the order going to be here, Mithali? Very correct. We will do what? We will keep the inverse function first, and we will keep the logarithmic function next, as it is the isolate rule which has to be used, right? So now first we change the order of these functions, and thus here we have cot inverse of sec x minus tan x, which comes as the first function, right? And with that now is multiplied log of x, which is the second function, right? So as such here, cot inverse of sec x minus tan x is f1x, and log of x is the second function, and now their product is to be differentiated. Now you're quickly reminded of the rule that you're going to use, and thus here you say that if there is a product of two different type of functions, right, then if they be f1x and f2x, then it is to be integrated by parts, something like this. That is, the first function f1x is to be taken out, and you integrate the second function f2x, right? And after that you find out the integral of the product of the derivative of the first function, right, with the integral of the second function, and you further have to integrate this product again, so that's why you write another dx. Okay, now children, here when we talk about this formula, this is the formula of what? This is the formula of integration by parts. All of these things that I'm writing with different colored ink, right? So you also require to write it in your copies, either in school or your homework copies, or probably in the examination that you've got to go for, so the teacher knows that you're applying this rule. And better would be if you can put that in a rectangular box using a scale. Just don't do it like that, right? Otherwise it'll look dirty. Okay, so this is the formula of integration by parts that we've just discussed. Okay, so children, here now we will be employing this in integrating this. Okay, so let's start. So when we start this process, it looks as if this is a inverse trigonometric function. So obviously let's try and make this a little simple. I'm sure you people must have seen in inverse trigonometric functions chapter, when inverse trigonometric functions were differentiated, then they could have been further simplified to very simple functions. So the same thing that we're going to try and do here. So as such, here we now have here cot inverse of sec x, which can be written as 1 upon cos x, right? And then further here you have tan x, which can be written as sin x, which is divided by cos x. That is all that you learned by simple trigonometry, right? And children, remember that this is multiplied with log of x, and here you can also put up a curly bracket showing that this bracket is actually not multiplied with log x, it is actually the inverse function which is multiplied with log x. Okay, so these brackets actually clear a lot of things which otherwise can become an ambiguity either for you or for the examiner as to what you're actually trying to do. So now children, when we have to integrate this, now we are trying to apply a little bit of inverse trigonometric functions so that we can simplify the inverse function. So now children, we can obviously write this to be cot inverse of 1 minus sine x, which is to be divided by cos x, and here we terminate the inverse trigonometric function, and with that then we multiply log of x and further a dx. Now children, this looks to be getting simplified a little, as here you can write this to be cot inverse of this one can be written as cos square x upon 2, to which you can add sine square x upon 2, and this sine x can be written as minus 2 sine x upon 2. Don't worry Mithali, I'll tell you the formula just now. Cos x upon 2, right? And in the denominator children, here what we will do is we will write cos x to be cos of 2 times of x upon 2 and write its formula, that is cos square x upon 2, from which is subtracted sine square x upon 2. Right, now telling you people about the different formula that we've used here. So if children you talk about sine square theta plus cos square theta, I'm sure everybody knows that for the same angle theta, when you add the squares of sine and cosine, right, then that becomes equal to 1. You've studied this probably in class 9 or class 10, right? Everybody knows this, right? Okay, so this is one thing that has been used, that is in place of this 1, right? What have we written here is we have written this cos square x upon 2 plus sine square x upon 2. Now I'm sure there must be a question which must be popping up. Why is it x upon 2? That is because this x upon 2 is going to be very helpful for the second function, that is sine x, right? I'll show you how. Now children, if you talk about this sine x, right, it obviously can be written as sine of 2 times of x upon 2, because both of these 2's will get cancelled and then you will get sine x back. However, now that we've got this, to be 2 times of x upon 2, so this just becomes something like a formula of sine 2a, right? Now remember children, sine 2a is given as 2 sine a cos a, and that is the reason why this will be written as 2 sine of x upon 2 cos of x upon 2. So what was the primary formula? Yes Mithali? When you talk about sine 2a, and that's equal to 2 sine A cos A. And using this formula, we actually transformed sine x in this form. Now did you get to see that we have got x upon 2, right, for the angle of sine as well as of cosine, and that is the reason why, as this was true for any angle theta, in place of any angle we have just taken x upon 2 to be the angle, so that we can help modulate this and bring it to be something which I'll show you next. Right now, children, another formula is to be discussed, so I will discuss it next now with you. Remember, if we talk about cos 2x, right, then it has a formula which is cos square x minus sine square x. I'm sure you must have studied this in class 11 in compound and multiple angles. Now here, if we talk about this case that we have at hand, we just have cos x, remember. So obviously this can be written as cos of 2 times of x upon 2, like what we did for sine x, right? So again, this comes in the format of cos of some 2 theta, right? As such, this formula above can be applied, and thus we will have here cos square x upon 2, from which is going to be subtracted sine square x upon 2, right? Now next, children, here we further can do what? We can just substitute these values, right? And that is what I have done in the earlier step. Now is our task to simplify this. So here, children, I'm sure you people are able to see that if we talk about cos square theta plus sine square theta minus 2 sine theta cos theta, this just looks like cos theta minus sine theta whole square. As we know, children, that if we talk about a minus b whole square, then that becomes equal to a square plus b square minus 2ab. And further, then we also have another entirety down below, that is, we have something like cos square x upon 2 minus sine square x upon 2, which is just like x square minus y square or a square minus b square. And we also have a formula of that which you learned in class 9 in algebraic identities, that is, if you have a square minus b square, then that becomes equal to a plus b times of a minus b, right? So applying both of these formulae of algebraic identities, we can now transform our integration to be one that is trying to become as simple as possible. So outside we have cot inverse, and inside now in the numerator we can write cos of x upon 2 minus sine of x upon 2 and a whole square of this. Now, children, in the denominator what we have is, we have here cos square x upon 2 minus sine square x upon 2, right? And obviously here to this is multiplied log of x, right, which is the second function, right? And to show it, we will also close the brace bracket. Okay, remember, children, here if you talk about the numerator, as I told you, this is just like a minus b whole square, that is cos x upon 2 minus sin x upon 2 whole square, right? And that is what has been written here, right? Now if you talk about the denominator, as it is some a square minus b square, it can be written like a plus b times of a minus b, and that is what has been written here. That is cos square x upon 2 minus sin square x upon 2. I'll further rather change this just now. Why go to the next step? So further we can write this as cos x upon 2 minus sin x upon 2, and it can also be further multiplied with cos of x upon 2 plus sine of x upon 2, as this is just like a plus b times so a minus b, and it will become equal to a square minus b square. Now children, further we get to see here is 1 power of cos of x upon 2 minus sine of x upon 2 will get cancelled from the numerator and from the denominator. So we'll cancel 1 power, and from the denominator also we will cancel it off. Now why have I cancelled this 2? Because only 1 power of cos of x upon 2 minus sine of x upon 2 is left, as 1 power has already got cancelled. Now next children, what we're going to do is we will now be writing this as integral of cot inverse of cos of x upon 2 minus sine of x upon 2. Now Mithali is asking me, why am I writing this again? That is because in the last step you had this, you did the simplification. So first write what you got after simplification. If you try and hurry up the different steps, you will make mistakes, and then you will not be able to find out in an examination environment where the mistake is, right? And that is going to also put down the performance in other questions which are next, right? So better do step by step, go slow. Remember, practice comes only by speed comes only by practice, right? When you practice regularly, then automatically speed will come in calculation, in mental concentration, in writing properly, which are all the aids how you get full marks, right? Okay, so here children, next in the denominator, remember we have cos of x upon 2 plus sine of x upon 2, which is left. And then remember, this was multiplied with log of x, and here children, we close the bracket. No, not here. We will close the bracket here, right? And that shows that both of these functions are multiplied together. Next children, in the next step, what we do is we are now going to write this to be integral of cot inverse. And one thing that you can do, Mithali, here is you can take this cos of x upon 2 out common from the numerator as well as from the denominator. I'm sure you must be thinking that cos of x upon 2 is not there in the second term. Doesn't matter. If it's not there, we will just divide, right? So I'll just give you an example. Like say, if we talk about some a minus bc, right? And say from this, if we want to find out a common, then on taking a common outside, we will get 1 here. And as the second term doesn't have a, so obviously it will be divided by a. And this is what it will be. And obviously, if you multiply this a within, you will get back the same thing. That is a minus aa will get cancelled minus bc, right? And that is the reason, children, why here, when we take cos of x upon 2, we can take it common outside. The first term will become equal to 1, and the second term will become equal to sine of x upon 2, which will now be divided by cos of x upon 2, right? Then we close the bracket here, and in the denominator now next what we have is we have cos of x upon 2. Then again we will take it out as such, we'll just be left out with 1, and within then again we will have the ratio of sine of x upon 2, which will then be divided by cos of x upon 2. Right now, children, remember this function which has become a little large, right, which will now get simplified and become small. You will not be able to identify that this was that big function. I'll show you just now. Now this big function is multiplied with the smaller function. And what was that smaller function? The logarithmic function, right? So into log of x dx. Okay, so for the children, next what we're going to do is we will now write this as simplified to cos of x upon 2. Cos of x upon 2 will get cancelled, and we can write sine of x upon 2 upon cos of x upon 2 to be tan of x upon 2, isn't it? Because tan x is equal to sine x upon cos x, and that is what we're going to do next here. That is, now we will write here cot inverse of 1 minus tan of x upon 2, right? And in the denominator, children, we have 1 plus tan of x upon 2, right? Now, are you reminded about something, Mithali, here? No? Have you done your class 11, or you just passed somehow? Do learn all the formulae, all the concepts of class 11. Don't think that it is not going to come back in your life. It's always going to come back. So whatever has been learned should be very well learned, right? And when you have learned all of these concepts and are ready to apply it every now and then, that is when you will get employment. If you have knowledge and you can't employ it, right, then why will they employ you? Right? So make sure all the knowledge that is there with you is not just written in your register, it is registered here in your brain so that you can apply it when required. Okay, now children, after this, next what we're going to do is we will now be talking about further trying to write this as some other function. I will show you how by using a formula, right? Remember, children, when we talk about the formula, which is tan of a minus b, then that becomes equal to tan A minus tan B, which is divided by 1 plus tan A tan B. Right? Now children, here you get to see that you can write it this way. I'm sure you people are mesmerized. How is it possible? Because if you talk about 1, there is no tan. If you talk about the denominator, there is no second function, as there's just tan of x upon 2. Don't be worried. Remember that 1 can be written as tan of pi by 4 or tan of 45 degrees, and that is what we're going to use so that we have the second tan, right? And as such, here we will come back to our original function, and we will now here write integral of cot inverse of tan of pi by 4, from which is subtracted tan of x upon 2, and then children, in the denominator you will have 1 plus tan of pi by 4 multiplied with tan of x upon 2, as wherever there is 1 we can replace it to be tan of pi by 4, because tan pi by 4 or tan 45 degrees is 1, right? Next, now children, after this what we do is we can now write this to be multiplied with log of x, right? And obviously there is a dx, and then next what we can do is we can write this as cot inverse of a very simple function, that is tan of pi by 4 minus x upon 2, right? Because if we talk about tan of a minus b, this is just like tan of a minus b, which has yielded you this result, right? And thus this result can be written as tan of pi by 4 minus x upon 2, just that as here in this equation you have the left hand side, right? Okay children, after this, next now what we do is we will now multiply this further with log of x, which is the second function, right? And try and simplify this so that cot inverse and tan can be cancelled off. So what you do here is, I'll tell you another formula here. So if you talk about tan of theta, then do remember that tan theta can be written as cot of pi by 2 minus theta, right? Because you know that cot 90 minus theta is equal to tan theta. Similarly, tan of 90 minus theta will become equal to cot theta. So here, as we have to convert this tan to cot, right? So in place of this tan of this angle, we can write cot of 90 minus theta, where theta is actually this complete angle. So here what we've considered is we've considered this complete angle pi by 4 minus x upon 2 to be theta, right? So now children, in the next step what we can do is we can replace this value, and we can find that everything is going to topple down, become a very simple function. So we now have cot inverse of cot of pi by 2 minus this angle, which is pi by 4 minus x upon 2, right? Now children, here what we do is we put this bracket, right, and then further multiply this with log of x, and as this is a different function, so again here too we put up another bracket. Now we find that everything is melting down, and cot inverse and cot will now be found to be cancelled off, right? And thus we will now be just left out with pi by 2 minus pi by 4 will become equal to pi by 4, that is 45 degrees, minus minus will become equal to plus, that is plus, and then we have further x upon 2. So this now from an inverse trigonometric function has now become an algebraic function, and it is multiplied with log of x, which is a logarithmic function. So children, now tell me which is going to be the first function, as this now is a product of two functions, f1x and f2x. In accordance with integration by parts, which is the function which is to be written first? Don't see from your copies. What have you been doing till now? Okay, just focus, and when something new has been taught to you, register that in your brain. Okay, so as it is I late, as simple as that. I also gave you the mnemonic. So what you're going to do is you're going to keep the inverse trigonometric function first in the order, then logarithmic, then algebraic, then trigonometric, then exponential, right? So here you find that the logarithmic function requires to become f1x and the algebraic function requires to become f2x. And this is the next change that we're going to do. That is, we will change the order of the functions in which the functions are multiplied to be able to be integrated. So log of x, which is then multiplied with this algebraic function, which now is pi by 4 plus x upon 2, right? So this is now the product of both of these functions, and we have to integrate this. Okay, so as we know that we have a formula for this, so we'll quickly write it. That is, if we have the integral of one function f1x which is multiplied with another function f2x and their product is to be integrated, then this becomes equal to the first function f1x taken out integration of the second function f2x, which is further from which is subtracted the integral of the derivative, rather the product of the derivative of the first function, that is f1x, right, to which is multiplied the integral of the second function, right? And here what you will do is you will put up a dx for this and another dx, as there is to be another integration, the final integration, right? So we will now have to apply this in this product of two functions, right? So to do it, we come to the next step. Now we write here log of x, which will be taken out, and then we have integral of this second algebraic function, that at the moment we just write it by putting it in the formula, that is pi by 4 plus x upon 2, right, dx, and from that is to be subtracted the derivative of the first function, that is d upon dx of log of x, right, to which is multiplied the integral of this second algebraic function, which is pi by 4 plus x upon 2, right, and then further we have a dx here, and that is what we want to do, right? Now children, remember, as this has to be reintegrated, so we also put up a bracket here, right, and we write another dx. So next, now children, what we do is we come over to the next step where now we have to further simplify. So this becomes equal to log of x, which is multiplied with the integral of this algebraic function, which is damn easy, baby's work. So obviously pi by 4 being a constant will come outside, and the integration of x raised to the power 0 is x raised to the power 0 plus 1 upon 0 plus 1, that is just x, right? And then when you talk about the second function, again 1 upon 2 is going to come outside, and the integral of x will become x raised to the power 1 plus 1 upon 1 plus 1, that is 1 upon 2 times of x squared divided by 2, right? And further children, if you talk about the next function, as the derivative of log of x will become equal to 1 upon x, so now we have the integral of 1 upon x, which is multiplied with the integral of this, which we've just found out, right? Just remember, if you talk about the integral of this pi by 4 plus x upon 2, we are doing it for the second time, so obviously whatever its value came, we can write it here, right? And that is what we will do here. So here children, we will now have the integrated function to be what we just had, that is x plus x square upon 4, and then children, we can write a dx here, right, as it requires to be integrated once more. Okay, so here further we have log of x, which is multiplied with x plus x square upon 4. You got to do nothing in this, right? And then in the second function, it can be integrated again very simply, as you have 1 upon x outside, and here in the numerator also you can take this x to be common outside, and then you will be left out with 1 plus x upon 4, right? Next children, what you'll be doing is, here further we will have both of these x's cancelled, as both of these are common and in product form in the numerator and in the denominator, so they will get cancelled. So the next step, now we will write here log of x, which is multiplied with x plus x square upon 4. Yeah, Mitali, you want to take the x common outside? Yeah, you can do it, but I feel that there is no importance of that. If you do it, then it's fine, no problem. Okay, so what will happen next is you will have minus the integral of the leftover function, which is just 1 plus x upon 4, Now it's boiled down to a very simple integral, isn't it? And I'm sure everybody is all smiles. That is how you should be when you are able to get to the solution of a sum. But all through, you got to put your concentration as it is, right? Because only then you'll be able to understand everything what all has been taught to you people. Okay, so after this then we write the integration of 1, which obviously is going to become equal to x, and we'll put up a bracket here because this minus is multiplied to the sum of both of these functions, right? Now further, the integration of x will become equal to x square upon 2. As such, this will become x square upon 4. Now children, there is a rule that I've been applying every now and then, that is, if you talk about the integration of some x raised to the power n dx, then remember this becomes equal to x raised to the power n plus 1, which is divided by n plus 1, and to which the constant of integration c is added, right? And that is why I have done this. Okay, so here children, as the integration is complete, so you can write this added with the constant of integration, which can be remembered to be the constants which actually would have been here. If they are not there, obviously c will become equal to 0. And remember one thing more, when you find out the value of c, right, you're trying to find out the specific solution to the question, right? And then in that case, you should be given what is the value of x when you got the value of y to be something, right? So x and y should be given to you, and when you replace that in the equation, right, you will find out the value of the constant c. Okay, so this children is going to become the final answer to this question. Now all of this I will quickly repeat to you people, right, so that you can then understand everything, right? You want to hear the joke? Okay, I'll quickly tell you the joke and then come back to this, and then further we will be discussing something about Greenland, which I'm sure is going to be an increase in your knowledge and will also give you some lesson in life. Okay, now can you tell me what the people of Greenland are known as? I'm sure after I've told you people, right, you will say that I knew it. No, don't Google it. No, don't ask your friends. I'm sure nobody here in class knows. I'll tell you. If you talk about the native people of Greenland, they are known as this. And that is why I told you that after I've told you, you will say, I knew it. That is how everybody wants to show that they are very smart. Okay, so this is I, and this is NU can be said to be new, right? And this is it, right? And actually INUIT is the native of Greenland, right, which are very few in number in accordance with the last census that was done there. Although Greenland is very large, was just approximately 55,000 people, right? So to the maximum it might have increased to say some 75 or 1 lakh people, right? More so because many foreigners also staying at Greenland, because there is a lot of mining which is happening there, because it is very rich in the rich minerals like gold, lithium, uranium, etc. Okay, so we'll come back to all of that, but I'll first like to discuss with you people the solution to this question once more, so that if there is any speck of doubt left, all of that gets cleared. Okay, so we had this long question which boiled down to a very simple answer, and all of that is now going to come back, so that there is nothing that you can say, sir, that I didn't understand, right? Even though if you understood, I like you people to stay here till the end so that you can understand this once more, and the understanding becomes wholesome. Because remember, after you've understood this, I made you people do a promise that then you're going to pick up your copy and your pen, and without looking at the solution, you will redo the sum, right? And when you do it for say some 3-4 sums, you will understand how doing the sum once again after the teacher has explained has a resounding effect on your learning, right? So excuse me, let's quickly try and understand what all happened in this sum. We had to find out the primitive. Remember, the primitive is also known as the integral, right? What is actually primitive people? They are the people who were there before us. I mean, the people who are much before us, they are said to be the primitive people. Same here when we are trying to get the old function back, like I told you earlier. That is when we have a function f of x, and when we try to get back the function f dash x from f dash x, the old function, right, f of x, right, then we say that we are trying to integrate it, right? This is the process. So initially we differentiate a function, get to a derivative, and then when the derivative is integrated, we get the old function back. So obviously this is just like the old man, and thus we can say that this is finding out the primitive, right? Okay. So just like finding out the old functions back is possible in mathematics, I think if this would have been possible in real life, I think many people who passed away, who were really good people, can be brought back. Yes or no? Do tell me in comments, right? Who was that person who you will really like to bring back to life? And obviously at the beginning, don't forget to write Alu so that you can remember that if you go to Greenland, what are you going to say? Yeah, I'll tell you about that sweet delicacy. I still don't think that you're that hungry. Okay, just wait for the second explanation. Okay, so if you have cot inverse of sec x minus tan x, which is multiplied with log of x dx, then this is actually the product of an inverse trigonometric function with a logarithmic function, which is a typical entity, as all such sort of functions won't be integrated, right? Because you know that whenever you talk about inverse trigonometric functions which are there, then just to integrate them you write dot 1. Similarly, when you are to integrate logarithmic functions, in order to integrate it, again you write dot 1, convert this ones which have come later to x raised to the power 0, make them algebraic functions, and then apply the integration by parts formula, right? So that's why this becomes a little dubious question and becomes important. Now the formula for integration by parts is if there are two functions which are multiplied together, like f1x and f2x, right, and both of these functions, remember, are two functions of different types, right? What were the different type of functions that we just discussed? One was inverse, the second was logarithmic, third was algebraic, fourth was trigonometric, and the last was exponential. So we can expect any of these functions to be paired in product for integral. For this you have to remember I late. Think that you got late to school, that normally happens, right? And from this mnemonic you'll be able to remember that this is to be the order of the functions which is to be integrated. If you keep the functions which are of a specific type in accordance with this order of alphabets, you will find that the integration will happen easily. Otherwise you just won't be able to integrate. For that, you require to remember that when we do integration, it is only possible for a few set of functions. You talk about just any Tom, Dick and Harry type of a function and you want its integration, it can't be done. Okay, so next now children, what we do next is we further try and simplify this inverse trigonometric function. As you've seen in inverse trigonometric functions, the differentiation of inverse trigonometric functions, sometimes it boils down to so simple functions. So we can just give it a try. So here what we do is, after writing this formula of integration by parts, next now we start breaking this function which is inside the inverse trigonometric function, a trigonometric function, down. So sec x can be written as 1 upon cos x, tan x can be written as sin x upon cos x, right? And further we have still this log of x waiting outside, as you normally wait when you go to a friend's place whom you want to meet, but probably their parents know that if you meet them, it will not be good for their children. Okay, they make you meet stay for a long period of time, and after that they say that okay, go and meet, but come back in 5 minutes. Right, this is what normally happens. So now children, when we talk about now this inverse trigonometric function which further requires to be simplified, we further have here that both the denominators are exactly the same. As such, the LCM will also be cos x, and in the numerator we can write 1 minus sin x. Fine, so this has got simplified a little. Now children, we quickly identify that this one can be written as cos square x upon 2 plus sin square x upon 2, because we know that sin square theta plus cos square theta for any angle theta will be 1. So if the angle is x upon 2, no problem. And then you are reminded that this sin x also has a formula, that is sin 2a is equal to 2 sin a cos a, and as such sin x can be written as sine of 2 times of x upon 2, as both of these 2's will get cancelled and you will get sin x. So as such, this becoming like sine of 2a, this can be written as 2 sin a cos a, right? And that is what we have here. Now further children, we keep all of these values. For the second value, we have minus 2 sine x upon 2 times of cos x upon 2. Now we come to cos x, how it can be broken down. So again, children, we can remember that if we talk about this cos x, we can write it to be cos of 2 times of x upon 2, as both of these 2's will get cancelled and we'll get the cos x back. However, we will try to get an advantage out of this, as we remember the formula of compound and multiple angles. Cos 2x is equal to cos square x minus sine square x, right? So here too we apply it. We now can write this as cos square x upon 2 minus sine square x upon 2, and now we replace it here, right? Okay, so thus now we get to see that in the numerator we actually have something like a square plus b square minus 2ab, which actually is the value of a minus b whole square, right? And thus we write it that way. That is, we now write this in the numerator to be cos x upon 2 minus sine x upon 2 whole square. In the denominator, children, we get to see that there is something like a square minus b square, and we know by algebraic identities that that is equal to a plus b times a minus b, and then we write that value. Now we get to see that a minus b is there in the numerator multiplied together, right, as square will mean that this has come twice, and in the denominator we also have a minus b. So both of these terms will get cancelled from the numerator and from the denominator, as they're identical, and also in multiplication. If there would have been a plus sign in between, you wouldn't have been able to cancel it, right? Okay, so next now you have here cos x upon 2 minus sine x upon 2, which is divided by cos x upon 2 plus sine x upon 2. Now children, here we do one more trick. That is, if we take this cos x upon 2 outside from the numerator and from the denominator without its will, that is forcefully, right? So what will happen here is, here where there it is, then obviously there'll be 1 that will come, and where it is not there, obviously we will have it to be that term divided by cos x upon 2, as it was not there, right? And here, if you want to get back to the old step, that can easily be done. If you take an LCM, it will become cos x upon 2, right, and minus sine x upon 2, and then further this cos x upon 2 with which it was divided will come outside, right? So you will get the old function back. Now children, in the denominator also we have taken cos x upon 2 outside. As such, here we will get 1 plus sine x upon 2 divided by cos x upon 2. Now children, by the trigonometry of class 9, you know this, that sine x upon cos x is tan x. As such, this is going to become equal to tan of x upon 2, and rest obviously everything remains to be the same. In the denominator also you will get tan x upon 2, right? And further here you are reminded that this can become something like tan of a minus b. How? If we take this 1 to be tan of pi by 4, and then in place of this 1 into tan of x upon 2, which you can imagine, we can write this one again as tan of pi by 4, and then it will become something like tan of pi by 4 minus tan x upon 2 divided by 1 plus tan of pi by 4 times of tan x upon 2. And as this is the same as tan of a minus b, so it will become tan of pi by 4 minus x upon 2, right? Now children, another problem. We have cot inverse and tan here. Obviously they can't cancel each other, so what to do? Then you remember of a formula, tan theta is equal to cot of pi by 2 minus theta. That is, tan theta can be got by writing it to be cot of 90 minus theta, as pi by 2 is the same as 90 degree, right? So as such, here what will happen is cot inverse and cot will get cancelled, and then you will have pi by 2 minus this value of theta, which is pi by 4 minus x upon 2. Now children, next what you'll do is, as pi by 2 minus pi by 4, that is 90 minus 45 will become equal to 45, so you'll be left out with pi by 4, and minus minus will become equal to plus. As such, you have x upon 2 added to it, and that is then multiplied with log of x, right? And it is further obviously multiplied with dx, which shows that you're doing integration, which normally makes sense when you talk about finding out the area under the graph that you will get to learn in definite integration, right? In times to come, then I will be explaining everything to you in detail, making the graph and showing you the different portions. So here children, now we are left out, in place of an inverse trigonometric function, an algebraic function which is multiplied with a logarithmic function, right? So if you quickly remember the order of the alphabets late, you remember that a logarithmic function should be first in the order of functions, and then to it should be multiplied the algebraic function. In your examination, make sure not to write this. This is just for your understanding. So this is just a mnemonic, this is no rule, right? You can just say that if we change the order, then it will become integrable. Okay, so next now children, what will happen is you will now write thus the logarithmic function first, and then you will write the algebraic function. Now using this rule of integration by parts, taking the first function outside, integrating the second function, minus the integral of the product of the derivative of the first function with the integral of the second function, right? The second dx, because you've got to integrate again, is to be applied. Now here as such, what will happen is you will now have log x taken outside, integral of this algebraic function, right, minus integral of the derivative of log of x times of integral of the algebraic function, right, integrated again. Now when we write the integral of this algebraic function, it's pretty simple, right? Constant is going to come outside, integration of 1 will become x raised to the power 0 upon it is when we talk about integration of 1, it is actually integration of x raised to the power 0. That will become x raised to the power 0 plus 1 upon 0 plus 1, as I've discussed here also in the formula which has been used. That is, integration of x raised to the power n dx will become equal to x raised to the power n plus 1 upon n plus 1. So here children, we have it thus to be pi by 4 taken outside, right, and with that then is going to be multiplied here x raised to the power 0 plus 1 upon 0 plus 1. So here I have made a small mistake, and there should be a pi by 4 here which was taken common outside, right, and inside then we talk about the integration of the second function. So 1 upon 2 taken outside, the integration of x will become x raised to the power 1 plus 1 upon 1 plus 1, that is x square upon 2. Now children, we come over to the functions after the minus sign. Then we write the derivative of log of x, which is 1 upon x, and we multiply it with this integral which we've just found out. So we can just write it like that. So here too, the same mistake is going to take its toll. So we have a pi by 4 here. Now we have 1 upon x, which is multiplied with pi x upon 4 plus x square upon 4. So next children, here what's going to happen is we will now have this x cancelled off, and now we will have here left out with pi by 4, right, plus x upon 4. So in the next step on integrating this is going to become equal to pi by 4, right, and as x has already been taken outside, right, and cancelled off, and next now we'll integrate this again. So this pi by 4 will go outside, get multiplied with the integration of 1, that will become equal to x, right, and to that is going to be multiplied the integral of x, which will be x square upon 2, right, to be multiplied with this 4, and as such it will become x square upon 8, right, plus c, and this children is going to become the final answer. So this is all that you do in the sum. So I hope you've been able to understand all of this. Now you want a joke. Okay, one joke I've already told you. Now I'll tell you another joke of Greenland especially. Now once what happened was there was a robbery in the very few people who used to live at a place, right? So the policeman deputed came there, asked, okay, one gentleman, he asked, on whom he had a thought that probably he can be one of the people who came for theft. He asked him, okay, just tell me, where were you from the mid of March to rather the mid of October to the mid of March? And this person actually had come from outside, was just a tourist, and thus he was perplexed. He's saying that such a long period of time I am not able to remember, right? And when he said this, he was caught. Why? Because it is actually customary that it is winter conditions, right, and there is no sun for this period of time, which is approximately from the mid of October to the first week of March, right? Moreover, I think from the 11th of October to the 4th of March, right? And obviously that varies in accordance with the solar conditions. So as such, this person was very easily able to catch this thief. Okay, right? So because he understood that this is not a native of this place. What are the native known as? I knew it. Okay, so this was a simple flimsy joke. I think, have you enjoyed it? Okay, you have enjoyed it, right? So one thing more, if you talk about Greenland, right, there are a few more very essential facts. That is, it is an island which is the largest, and its expanse is from above the Arctic Ocean to also above the North Atlantic Ocean. So you can understand how large it is. But even though it is so large, it is not a continent. Okay, now children, about the sweet delicacy of this place, well, I'll tell that to you after I give you a moral lesson of life, which we can get to learn if you get to tour Greenland as I did. Now, the first thing is that it all starts from the global warming, right? There is such a lot of global warming which is happening the world over, as so many fossil fuels are burning. There is such a lot of carbon dioxide which is going into the environment, which is one of the greenhouse gases which accumulates the heat and doesn't let it go. As such, the temperature of the whole planet is increasing. And as such, what's happening is the glacial ice is melting in places like this, right? And that in turn is increasing the sea level, right? And when the sea level is rising, it will be a threat to many islands, as now next they will all be immersed under this elevated level of sea. There's another problem. The sea ice is getting melted. The sea ice means it is just like the topping of the water which is on the sea in such places which normally stay at sub-zero temperature. Now, when the sea ice melts, then what happens is the carbon dioxide comes in contact with the seawater, right? And then it acidifies this water, which further through the seawater goes over, given world over, right? And this destroys the marine life. As such, the marine life also is something which is under threat. So remember, as these people portray us, that when they have low resources, very low resources, as remember, food resources are just some berries which grow, right? Because there is no major plantation which happens here. Then you can just stay alive either by hunting or by fishing. Moreover, you don't even have roads, right? The transport is only possible through ferries which run on these rivers between the fjords, or you can even just move by dog sledges, nothing else, right? So when there is so little, they are able to plan their existence, right? So we should also try and understand that we shouldn't waste the resources that God has provided us so very easily. We have water, we have clean air, right? And we have multiple other resources, right? So remember, children, that you have to ensure that conservation of nature is done. Only then the generation which is to come will be able to live comfortably. Otherwise, they are the people who are going to tell that these people were very spendthrift in accordance with the resources that God had given us. Okay, now children, to tell you quickly about the sweet delicacy, as I'm sure that as you've been through all of this journey of me taking you to showing you the place, teaching you the different fundamentals, then the sum, the second explanation, I'm sure you must be really hungry. And I think that you've been a true child and you've been studying this lecture all through just in one go. Good, Mithali. There are others like you. So there is one sweet dish which is very, very famous in this place, and which actually is one which is made with raisins and with cardamom, right? Cardamom, you know, it's a spice. Yeah, it's made with that, and it's very good to eat, although it's a very simple sweet dish. It's just like a bread which is made with these ingredients, and it's got a special name, right? And the name is what? It is something that I have forgotten a little, but I'll tell you. That is actually Kalit Kagiyat, right? And in such resources, when you're even able to get to this, then it's awesome, right? So children, do take a tour to Greenland. I'm sure you will enjoy this, right? And let us pray to God that tomorrow it stays, because all the glaciers are melting very fast, right? There is a mechanism by means of which you can measure the glacial speed, that is the speed with which the glaciers are moving, because they're melting and they're moving on that water, and that has increased phenomenally. So let us also be a little sane, use the resources properly, and spread awareness to everybody that they should be taking care of the resources, right? With that said, a big bye from my side. Make sure that you practice this just now, right? And enjoy your life. Bye.